let's look at another example of momentum conservation. In a head-on collision, an 1,100 kilogram sports car traveling to the right at 85 miles per hour, which is 38 meters per second, hits a 1,600 kilogram SUV. It's traveling to the left at 65 miles per hour, which is 29 meters per second. If they stick together during the collision, determine their velocity after the collision. So let's draw a picture of the situation. First, I'm going to divide it up into before and after. So on the left is going to be my before. On the right is going to be my after collision. Here's my sports car. Moving this way along the road. It's going to collide with an SUV. Not the greatest SUV. Moving to the left. So I know that the mass of the sports car, I'm going to call that object 1, is 1,100 kilograms. I know that the mass of the SUV, I'm going to call that object 2, is 1,600 kilograms. So I'm going to call this V1 initial. The mass of this, the velocity of the sports car is 38 meters per second, right? I'm gonna grab the metric measurement, and then the initial velocity of the SUV, V2 initial, is 29 meters per second here. Okay, but I want to show that it's moving to the left mathematically, so I'm gonna call that negative, and I'm gonna like really highlight it here, right? Negative 29 meters per second. Okay. All right, and then after the collision, they stick together. Okay, so they get tangled up in this accident, and I've got this sort of jumbled mass of collided cars. The SUV has gotten wrecked in the process. And they're going to move in some direction. They're going to move to the left or to the right. I don't know. So I'm just going to call that V. The velocity of both objects, velocity of objects 1 and 2, final, is my unknown. I don't know how fast they go after they collide. All right, so there's my starting picture. And you know what? I can actually add this. So I can say that M1 plus M2, I know that their combined mass after is going to be 2,700 kilograms. I can say that. All right, let's use the law of conservation of momentum. So we're here, use the law of conservation of momentum to determine the velocity of both cars after the collision. That was this part. All right, so first, what kind of collision is this? So keyword here was stick, right? If they stick together, that is called an inelastic collision. An inelastic collision. So I'm going to use the momentum conservation equation for an inelastic collision that goes like this. M1v1 initial plus M2v2 initial is going to be equal to the combined momentum of both cars, combined mass of both cars times their common velocity afterwards. Okay? So here we go. We've got an 1,100 kilogram sports car moving at 38 meters per second, and we have a 1,600 kilogram SUV moving at 29 meters per second to the left. So I'm using the negative, and I'm going to set that equal to their combined mass afterwards, which is 2,700 kilograms, and then their unknown velocity. Okay, so on the left side, I end up getting negative 4,600 kilogram meters per second of momentum. On the right side, I get 2,700 kilograms times the final velocity of both objects. And so that means that the final velocity is going to be negative 1.7 meters per second. Okay, so it turns out they are going to move to the left at 1.7 meters per second. Now, part C, right? Explain the outcome of the collision. Why did the cars move the way that they did? So specifically, why did they move to the left after the collision and not to the right? Well, the direction is determined by the car that has the greater momentum to begin with, okay? Look at how much momentum the sports car has at the beginning, okay? It's got a mass of 1,100 kilograms, but it's moving at a velocity of 38 meters per second. Okay, so its initial momentum is 41,800. Okay, so I'm going to say that the initial momentum of the sports car was 41,800 units of momentum, right? What about the initial momentum of the SUV? Well, the SUV here has an initial momentum of 1,600 times negative 29. And that is 46,400. So the initial momentum of the SUV is 46,400 in the opposite direction, right? So the cars move in the direction of the object that had the greater initial momentum, right? So the cars move leftward after the collision because the SUV had more momentum initially. It had more initial momentum. And you can use that kind of logic anytime you're predicting the direction that the objects are going to move after the collision, okay? Whichever object has more momentum is going to sort of win and will determine the direction of the objects after the collision.